In this video, we're going to focus on significant figures, the rules behind addition, subtraction, multiplication, and division. We're going to go over some examples, including some combined operations, problems where you have both addition, subtraction, and multiplication combined. So let's begin. The first thing that you need to be able to do is you need to tell how many sig figs are in a certain number. So for example, how many significant figures are in the number 73? The first rule that you need to know is that non-zero numbers are always significant. So 7 and 3 are significant, so there's 2 sig figs in this number. 468 has 3 significant figures. 7,651 has 4 significant figures. Now what about 703? How many significant figures are in this number? So whenever you have a zero between sig figs, between significant numbers or non-zero numbers, the zero is significant. So therefore, we have 3 significant numbers. So what about 5,006? So here we have 4 sig figs. Now what about 7,030? How many sig figs do we have? Trailing zeros, that's a 0 to the right of a non-zero number. Trailing zeros are non-significant if there's no decimal point. So this 0 is not significant. So therefore, we only have 3 significant figures. Now, what if we have 7,030 with a decimal point? So now this trailing 0 is significant. So we have a total of 4 significant figures. 1, 2, 3, 4. Try these examples. 50, 500, 500 again, 500.0, and 50,060, and 50,060.00. So trailing zeros are non-significant if there's no decimal point. So this 0 is not counted. So here we only have 1. This is also 1 sig fig. Now we have a decimal point, so each of these are significant. So therefore it's going to be 3. This 0 is also significant due to the decimal point, so this is 4 sig figs. For this one, the in-between zeros are significant, including the 5 and 6, but not this 0, because there's no decimal point. So this is 4 sig figs. Now for this example, because we have the decimal point, every 0 that is to the right of a non-zero number is significant. So it's going to be 1, 2, 3, 4, 5, 6, 7. So we have 7 significant figures. Now what about 0.004, 0.00435, 0.0708, 0.05060, and 0.30400. Leading zeros, that's zeros to the left of a non-zero number, in this case the 4. The leading zeros are non-significant. So anytime you have a 0 to the left of a 4, a 5, or a 7, it's not counted. So only this number is counted, even though there's a decimal point. So we have 1 sig fig. For the next number, only the 4, 3, and 5 are counted, so we have 3 sig figs. Now, here we have an in-between 0. It's in between 2 significant numbers. So that 0 is counted. So we have 3 sig figs. A 0 to the right of a non-zero number, like a 6, this 0 is significant because we have a decimal point. And this 0, which is between 2 significant numbers, is also significant. So therefore, we have 4 significant figures. And anytime you have a decimal point, any zeros to the right of a non-zero number are significant. So here we have 5 sig figs. So let's try a few more examples for the sake of practice. Try these: 0.035, 0.0306, 0.070080, 0.001, and 0.05040760. So don't count the zeros on the left of a non-zero number. So here we have 2 sig figs. For this one it's 3. For this is going to be 5. For this one it's only 1. And for the last one it's 1, 2, 3, 4, 5, 6, 7. So now let's go over some rules associated with addition. Let's say if we want to add 4.231 plus 3.51. How can we do it? What you need to do is add the two numbers like this. You want to make sure the decimal points are aligned. So 1 plus this imaginary 0 is 1. 3 plus 1 is 4. 2 plus 5 is 7. 4 plus 3 is 7. So when you add these numbers, you get 7.741. That is the exact answer. But we need to round it. So notice that you have 3 digits to the right of the decimal point, and for the other number, it's 2 digits to the right of the decimal point. You need to round it like this. Here the 1 is the digit that is uncertain. You're not sure if that value should be a 1, a 0, or 2. And this one is uncertain. So you have to round it to the least digits after the decimal point. So we're uncertain about the hundredths place, so we have to round it to the hundredths place. Here we're uncertain about the thousandths place, but we need to round it here. So all you need to do is draw the red line and stop after the 4. So the correct answer should be 7.74 if you wish to round it. Let's try a few more examples. So let's add 2.36 and 5.4. So we're going to draw the line, but we're going to add the numbers. It's going to be 6, 7, and 7, 7.76. But we need to stop at 7.7. But we still need to use the 6 to decide if we should round it to 7.8 or 7.7. If this number is 5 or greater, you need to round up. So we're going to round it to 7.8. Now here we're uncertain about the hundredths place, but here we're uncertain about the tenths digit. So we need to round it to the tenths digit. So it's 7.8. Try this one. 7.2361 and 8.42. So when we add it, it's going to be 1, 6, 5, 6. 7 plus 8 is 15. So we're uncertain about the 10,000th place and also the 100th place, but we're going to round it to the 100th place. So we need to round it to this number. That's where we're going to stop at. So we look at this number, we see that 6 is greater than 5. So we need to round up to 15.66 as opposed to 15.65. So this is the answer if we add the numbers. Now what if you get a problem that looks like this? 420 plus 3.51. And let's say there's a decimal point. How would you do it? So if we add these numbers, it's going to be 423.51. But we need to round it here. So the answer is simply 424. Now what if you have 500 and 1.365. If you add it, you get 501.365. Where would you round it? Notice that we don't have a decimal point. So that means that we're uncertain about the ones digit and the 10 digit. So we need to round to the hundreds place, which is here. So this is going to be approximately 500. Be careful with that question, because that could be tricky. Now what about this one? 45,300 plus 176.21. So let's add the numbers first. 1 plus 3 is 4. The other numbers are simply going to fall down. So it's 45,476.21. That's the exact answer, but where should we round it? So the 4, 5, and 3 are significant figures. The zeros are non-significant. So therefore, we need to draw the line at this point, right after the last significant figure. So what is the answer? That means this has to be the last significant figure that we're going to write. The rest should be zeros. So what we have is 45,476.21. And to the right of the line, we see that it's a 7. It's greater than 5. So we got to round up instead of down. So it's going to be 455. And then after that, we're going to add zeros. So 45,476 is close to 45,500. So this is going to be the answer. Now, we're not going to add a decimal point and make these zeros, because if we do that, we're going to have too many significant figures. We're only supposed to have 3 sig figs and not 7. So we won't add the decimal point. If we write it like this, only these numbers will be significant. But if we put the decimal point, these zeros will become sig figs. So we don't want that. So we're going to leave it as 45,500 without a decimal point. Now let's go over some examples associated with subtraction. What's 3.542 minus 2.1? So even though we don't have zeros here, you can treat it as if it's 0, because nothing is 0. So 2 minus 0 is 2, 4 minus 0 is 4, 5 minus 1 is 4, 3 minus 2 is 1. So the answer is 1.442. But now, where should we round it? So here we only have 2 sig figs, and for the other number we have 4. So we're uncertain about this digit. So we're going to draw the line right here. And since this number is less than 5, we're going to leave it as 1.4. We're not going to round it up to 1.5. So this is the answer. Try this one. 6.357 minus 2.47. So 7 minus a 0 is 7. 5 minus 7, that's going to give us a negative number. So what we need to do is borrow a 1. So the 3 is going to become 2, and the 5 will be 15. 15 minus 7 is 8. And you know what? Let's keep the 2 here. 2 minus 4 is negative. So we need to borrow a 1. This is going to turn to 5. And that's going to be a 12. 12 minus 4 is 8. 5 minus 2 is 3. So we can confirm that with the calculator. If you type in 6.357 minus 2.47, that's 3.887. Now, where should we round it? We need to draw the line here. And we can see the 7 is greater than 5. So we're going to round it to 3.89. So we have 3 sig figs. So what is 300 minus 47.465? So let's use the calculator. If you subtract these two numbers, you should get 252.535. Now, notice that the zeros are non-significant, so we're not certain about those digits. This is the most accurate number for 300. That's a significant number, so we're going to draw a line right here. So what should we round it to? So we're going to have a 2, but should we round it down to 2 or up to 3? Notice that we have a 5. So if it's 5 or more, you got to round up. So this is going to be 3, and then these two numbers, we're going to make them zeros. So it's going to be 300. We're not going to make these numbers zeros, because if we do that, we're going to have to write the decimal point, and these zeros will become significant. So we're just going to leave it as 300. So that's what you got to do for a problem like that. Now, what is 8.4 times 5? 8.4 times 5 is 42. Now, what are the rules for multiplication and division? So for multiplication and division, you don't need to line it up as we did for addition and subtraction. You simply need to round the final answer according to the least number of significant figures. So here we have 2 sig figs, and for this number we have 1. So therefore our final answer has to be, or has to contain 1 sig fig. So we need a number that's close to 42, but that has 1 significant figure. The best number that we can write is 40. 40 is close to 42 and it has 1 sig fig. So keep in mind, you want to keep the first number, but you need to decide if you should round it down to 4 or up to 5. We need to keep the first number because we need 1 significant figure. Because the 2 is under 5, we need to round down to 4, not up to 5. If we had 46, for example, and we wish to round it to 1 significant figure, because the 6 is greater than 5, we would round it up to 50. But if we had like 43, this would round down to 40. So what if we have this number? 279 times 83. So let's find the exact answer first. The exact answer is 23,157. So in this number we have 3 sig figs. Here we have 2 sig figs. So we need to round the final answer to 2 sig figs. So what number is close to 23,157 and has 2 sig figs? So at 2 sig figs, we need to stop here. So should we round it up to 24 or should we keep it down at 23? So the 1 is less than 5, so we're going to keep it down at 23. So these numbers after 2 sig figs, we're just going to make it 0. So it's going to be 23,000. That's close to 23,157, and it only has 2 sig figs. If we had 23,768, we would round it up to 24,000 if we want 2 sig figs. So let's go over some rounding examples. So let's say if we have 34,718. Now let's say if you want to round the number to 1 sig fig, what would it be? So we need to keep the first number 3. That's the number that we're focused on. Now, that number, should we keep it at 3 or should we round it up to 4? Because this number is less than 5, we're going to round it down to 3. So we have our first significant figure. Every other number is going to be 0. So the decimal point is really here. So we need to replace each of these numbers to the left of the decimal point with a 0. So it's going to be 30,000. Now, what if we want to round the same number but to two significant figures? So we need to keep the 3. Now the second number, which is going to be the second sig fig, we need to decide if we're going to round it down to 4 or round it up to 5. So we look at this number. The 7 is greater than 5, so we need to round it up. So we're going to round it up to 35,000. Now that we have our two sig figs, everything else is going to be a 0. So now, what if we want to round it to 3 significant figures? So we're going to need the 3 and the 4. Now the last significant figure, which is a 7, we got to find out if we should keep it at 7 or round it up to 8. So let's look at the next number, which is a 1. 1 is less than 5, so we're going to keep it down at 7. After that, we're just going to add zeros until we reach the decimal point. But we're not going to put the decimal point because that's going to change our significant numbers. Now, what if we need to round it to 4 sig figs? So we're going to keep the 3, we're going to keep the 4, and the 7. So now let's focus on the 1. Should we keep it at 1 or should we round up to 2? So looking at the next number, 8, it's above 5, so we got to round it to 2. And then the last number is going to be a 0. So that's how you can round to the appropriate number of significant figures. But now let's say if we have some numbers to the right of a decimal point. So let's say if we have 5,726.302. So what I want you to do is round this number to 1, 2, 3, 4, and 5 significant figures. So let's start with the first one. We only need one number, or one significant figure. Should we keep it at 5, or should we round it to 6? Looking at the next number, 7 is greater than 5, so we're going to round it up to 6. So we're going to have a 6, and then we need to add 3 zeros. Because at this point, there's going to be a decimal point, but we can't write it. 6,000 is close to 5,726. So we don't want 600 and we don't want 60,000. That's too far away from 5,726. Now, how can we round it to 2 sig figs? So we're going to keep the first number 5, and the second number is the one that we need to round, which is this number. So looking at the 2, we got to keep it at 7. We're not going to round it to 8 since 2 is less than 5. After that, we're going to add 2 zeros because we have a total of 4 numbers to the left of the decimal point. So in both cases, we're going to have those 4 numbers. Now, what about rounding it to 3 sig figs? So the first 2 numbers is going to be the same. The third significant figure, that's the one we got to worry about, and that's a 2. Because the number to the right of it is greater than 5, we're going to round the 2 up to a 3. And so we only need to add 1 0 because we just need 4 numbers since there's 4 numbers to the left of the decimal point. Now, what if we want to round it to 4 sig figs? So we're going to keep the 5, the 7, and the 2. We're going to focus on the 6. The next number is still less than 5, so we're going to keep it at 6. And we don't need to add anything because we have 4 sig figs. Now, if we want 5 sig figs, we're going to keep the first 4 numbers the same, but we're going to look at the 5th number. Since the number to the right of that is less than 5, we're going to keep the 3. And we need the decimal point at this point. And so here we have 5 sig figs. So now you know how to round a number to the appropriate number of sig figs. So now let's do a few more examples with multiplication. Try these two. Multiply 3.46 by 2.1 and 9.365 times 14.315. So the first thing we need to do is just type it in. 3.46 times 2.1, that's 7.266. So here we have 3 sig figs. and here we have two significant figures. So rules for multiplication and division need to round to the least number of sig figs. So we want two sig figs. So we're going to write the 7. The last sig fig is the one that we have to worry about, the 2. So should we round up or down? Looking at the 6, it's more than 5, so we got to round up. So we're going to round it up to 7.3. So that's the answer for that one. Now what about multiplying the other two numbers? 9.365 times 14. This is a 1, by the way. 14.315. So when you multiply these two numbers, you should get 134.05997. You always want to get the exact answer at first. So now, in this number, we have 4 sig figs. Here we have 5. So we need to round the final answer to 4 sig figs. So we're going to keep the first 3 numbers. The 4th sig fig, we got to focus on it, which is the 0. So looking at the number to the right of the 0, it's a 5. That means we got to round up to 1 and not down to 0. So it's going to be 134.1. Now the rules for division is the same as that for multiplication. So let's try these two examples. 32.6 over 2.8, that's a form of division. Sometimes you might get numbers that are presented this way. So go ahead and try these two examples. Feel free to pause the video. So let's divide 32.6 by 2.8. So the exact answer is about 11.64286. So here we have 3 sig figs and here we have 2. So we got to round it to 2 sig figs. So we're going to keep the first number. The second number, we need to round it. So since the 6 is higher than 5, we're going to round the 1 up to 2. So we're just going to leave it as 12, since it has 2 sig figs, and 12 is fairly close to 11.6. So now for the next example, let's type the numbers in the calculator. 464.6895 divided by 12.145. So you should get 38.26179,498. So in this number we have 5 sig figs. Here we have 7. So we got to round to 5. So we're going to keep the first 4 sig figs the same. 3, 8, and 2, 6. The last sig fig is the one that we may have to round. So we're either going to keep it at 1 or round it up to 2. 7 is greater than 5, so we're going to round it up to 2. So it's going to be 38.262. So now let's try some examples where we have combined operations. Let's say if we have multiplication and division. So if you have 3.6 times 4.639 plus 5.831, what do you need to do here? Now what you want to do first is find the exact answer. You do not want to round in the middle. You don't want to round intermediate answers. So let's multiply 3.6 by 4.639. That's 16.7004. By the way, you don't want to add 4.639 and 5.831 because you need to follow the order of operations. So if you remember PEMDAS, please excuse my dear Aunt Sally, you need to do multiplication before you perform addition whenever you're evaluating numbers. So now let's add 16.7004 plus 5.831. So the final answer, or the exact answer, is 22.5314. So now we got to figure out where we should round this answer. So looking at multiplication, which was the first step that we did, here we have 2 sig figs. and here we have 4. So the result for that number, we need to round it to 2 sig figs. If you round this number, it should be 17. But you don't want to add 17 and 5.831. If you do, that's going to change your answer. But you want to keep track of it. So therefore, this number should contain 2 sig figs, but we're going to use the exact answer to get this value. Now, this number has 4 sig figs, but we're doing addition. And for addition, we need to line up the numbers. So let me see if I can fit it in here. 5.831 plus 16.7004. So the 7 is the last significant number that we need from 16.7004. And it's in the ones digit or the ones unit place. So here's the ones unit. That's where we have to round. So we need to put the line right here. Now when we add these numbers, we do get 22.5314. So we require only 2 sig figs. We got to stop here. So looking at this number, it's a 5. So instead of rounding down to 22, we need to round up to 23. So this is going to be the answer. So let's try another example like that. 8.9 times 3.564 plus 2.316. So 8.9 times 3.564, that's 31.7196. Now let's add 2.316 to that, and the answer is 34.0356. So this is the exact answer. So here we have 2 sig figs, and in this number we have 4. So this answer should be rounded to 2 sig figs, which would be about 32. Now, if we add these two numbers, 31.7196 and 2.316, we get 34.0356. But notice that this number here is the last significant number for 31.7196 after multiplication. So since this is the last sig fig, we need to draw the line right here. Therefore, we only need 2 sig figs since we have 2 numbers to the left of that line. Looking at this number, we need to round down to 4 and not up to 5. So our final answer is about 34. Try this one. 9.24 minus 1.342 divided by 2.3. So let's find the exact answer first. 9.24 minus 1.342, that is equal to 7.898, and if we divide that by 2.3, the exact answer is 3.43391. So since we perform subtraction first, we need to line it up. So if we draw the line, we could see that the hundreds digit is the least significant number. So that's where we have to round. So if we were to round this value, notice that we have to round this number up because 8 is greater than 5. So to round 7.89 up, it's going to be 7.90, which means after subtraction, you get a number that has 3 sig figs, but you don't use this number in your calculation. You simply use it to track the number of sig figs. So after subtraction, we have 3 sig figs. And so for division, we're going to divide it by 2.3, which has 2 sig figs. So for division, you need to use the number of least significant figures, that's 2. So our final answer should have 2 sig figs. So therefore it should be 3.4. Since this number is less than 5, we're going to keep the 4 the way it is. We're not going to round it to 5. And so that's the answer for that problem. Try this one. 7.856 plus 8.23 plus 11.4 divided by 8.9. Now we need to add first. So let's line up the numbers. (7.856) plus 8.23 plus 11.4. That's 27.486. So the least significant number is the 10th digit. So let's draw a line here. So after addition, we should get a number that has 3 significant figures. That number would be rounded to 27.5, even though we're not going to use 27.5 in the calculation. To get the exact answer, we're going to take 27.486 and not 27.5. So we're going to divide 27.486 by 8.9. And so the exact answer is about 3.0883146. So after addition, we get a number that has 3 sig figs, and we're dividing it by a number of 2 sig figs. So according to the rules of division, we need to round to the least number of significant figures, which is 2. 2 is less than 3. So we get around this answer to 2 sig figs. So we need the 3, and we need one more number, which is a 0. So looking at the next number, we see that it's an 8, which is greater than 5. So we're going to round up to 3.1 instead of down to 3.0. So this is the answer for that problem. Now sometimes you may get a problem that has scientific notation with sig figs. So let's say if you get a question that looks like this: 3.61 times 10 to the 3 plus 5.1 times 10 to the 3. Whenever you add the numbers in scientific notation, to add 3.61 and 5.1, the multiplier has to be the same. Since it is, we could just add 3.61 plus 5.1. But let's line it up. We still have to follow the rules of addition. So when we add it, we get 8.71. So if we draw the line, we can see that the 10th digit is the least significant, it's the last significant figure in 5.1. So we're going to round 8.71 to 2 sig figs, to 8.7. So the final answer is going to be 8.7 times 10 to the 3. You don't have to use this number for sig figs. You only need to focus on these two numbers. Now what if we need to add two numbers that contain different multipliers? What should we do? We need to change one number into the other. Now it's going to require less work if you start with a smaller number and change it to the larger number. You can work with the 4 and change it to a 3. But eventually, once you get your answer, you're going to have to change it back into a 4. So it's easier if you change the smaller number into the large number. So how can we do this? How can we make the 10 to the 3rd 10 to the 4th? 5.4 is basically 0.54 times 10. Do you agree? If you multiply 0.54 times 10, you get 5.4. So we can replace 5.4 with 0.54 times 10. And 10 is the same as 10 to the 1st power. So therefore, 5.4 times 10 to the 3 is 0.54 times 10 to the 4. Whenever you move the decimal point 1 unit to the left, the exponent is going to increase by 1. If you move the decimal point 1 unit to the right, it's going to decrease by 1. So we need to add 0.54 times 10 to the 4 with 2.1 times 10 to the 4. Since the multipliers are the same, we can now write it like this: 2.1 plus 0.54. So we need to place the line right here, since the 1 is the last significant figure for the first number. So when we add it, it's 2.64. But we only need 2 sig figs. Since 4 is less than 5, we're going to round it down to 2.6. So the final answer is 2.6 times 10 to the 4. Now what if we need to multiply two numbers in scientific notation? Let's say if you have 2.1 times 10 to the 3, and we're going to multiply that by 4 times 10 to the 5. So first multiply 2.1 and 4, and separately multiply 10 to the 3rd by 10 to the 5. 2.1 times 4 is 8.4. Now whenever you multiply common bases, you need to add the exponents. 3 plus 5 is 8, so it's 8.4 times 10 to the 8. So now we need to round. Notice that the 2.1 has 2 sig figs, but the 4 has 1. For multiplication, you need to round to the least number of sig figs. So our final answer should have 1 sig fig, which is just 8. Since 4 is less than 5, we're going to round it down to 8 instead of up to 9. So it's going to be 8 times 10 to the 8. Try this one. 1.235 times 10 to the 5 multiplied by 2.3 times 10 to the 6. So first, let's multiply 1.235 by 2.3. So that's 2.8405. And if we add 5 and 6, that's going to give us 11. So notice that we have 4 sig figs here and 2 sig figs here. So our final answer should only contain 2 sig figs. That's 2.8. Since the 4 is less than 5, we're going to leave it as 2.8 and not as 2.9. So the final answer is 2.8 times 10 to the 11. Consider this example. 7.86 times 10 to the 3 multiplied by 5.4 times 10 to the 2. So 7.86 times 5.4, that's 42.444. And if you add 3 and 2, you're going to get 5. Now notice that this number is not in proper scientific notation. So we need to move the decimal point 1 unit to the left. Whenever you move it to the left, the exponent is going to increase to 1. So it's going to increase by 1 to 6. The proof for that is you can rewrite 42.444 as 4.2444 times 10. 4.2 times 10 is 42. 10 to the 1 times 10 to the 5, you need to add. 1 plus 5 is 6, so it's 4.2444 times 10 to the 6. So that's the exact answer. That's the answer you should get if you type the original problem exactly the way you see it in the calculator. Now, where should we round it to? So notice that we have 3 sig figs for this number, and here we have 2 sig figs. So the final answer should contain only 2 sig figs. Since the 4 is less than 5, we're going to leave it as 4.2 times 10 to the 6. So now let's go over an example that contains division. Let's say if we want to divide 9.37 times 10 to the 6 by 2.4 times 10 to the 2. So divide 9.37 by 2.4 first, and you should get 3.9041 6, 7. When you divide common bases, you need to subtract the exponent. 6 minus 2 is 4. So now we can round. So here we have 2 sig figs, here we have 3. So we got to round to 2. So the final answer is 3.9 times 10 to the 4. So that's all I got for you today. Hopefully this video will help you in your next chemistry or physics exams on significant figures. So thanks for watching this video, and I hope you have a great day.